Implicit function theorem. Theorem: state and prove implicit function theorem. Statement: let F be C dash mapping of an open set E subset of R raised to power n plus m into R raised to power n. If AB belongs to E, f of AB equals to 0, t equals to f dash AB, and t of x is a invertible, then there exists an open U is a subset of R raised to power n plus m, and open set W is a subset of R raised to power m with AB belongs to U and B belongs to W, such that to every Y belongs to W there exists a unique X belongs to R raised to power n with XY belongs to U and f of xy equals to 0. Further, if G such that G is a W to Rn, G such that W tends to R raised to power n is defined by G of y equals to x, y belongs to W, then G is a C dash mapping of W into R, GB equals to a f of G y equals to 0, y belongs to W, and G dash B equals to minus T of X inverse T of Y. Proof: let F be a mapping of E into R raised to power n plus m defined by f of x equals to f of xy, xy belongs to E. Then F is a C dash mapping of E into R raised to power n plus m, and the linear operator f dash AB on R raised to power n plus m is given by f dash AB HK equals to T HK K. H and K belongs to R raised to power n plus m. Now f dash AB HK equals to 0, which implies T HK K equals to 0 0, which implies T HK equals to 0 and K equals to 0, which implies H equals to minus Tx inverse Ty 0 equals to 0, which implies HK equals to 0 0 equals to 0, which implies f dash AB is 1 1, which implies f dash AB is invertible. Thus, the function f satisfies the condition of the inverse function theorem, and therefore there exists open set U and V in R raised to power n plus m such that AB belongs to U and f of AB equals to 0 B belongs to V. F is a function U to V is 1 1 and on to, and that G equals to F inverse is a C dash mapping of F into R raised to power n plus m. Let W equals to Y belongs to R raised to power m such that 0 Y belongs to V. Then W is not equals to phi as B belongs to W. Also Y belongs to W, which implies 0 Y belongs to V, which implies there exists an open sphere S in R raised to power n plus m with a center OY and a radius R such that S contains in V, which implies the open sphere S1 R raised to power n with a center Y and a radius R is contained in W, which implies W is a open subset of R raised to power m. Again, y belongs to W and 0y belongs to V equals to f of u, which implies 0y equals to f of xy for some xy belongs to u, which implies 0y equals to f of xy1 y1, which implies 0 equals to f of xy1 and y equals to y1, which implies f of xy equals to 0. Thus, y belongs to W and there exists ax belongs to R raised to power n such that xy belongs to u and f of xy equals to 0. Therefore, x is a unique because f is 1 to 1 in u, which proves the first part of the theorem. Second, defining a g function w to r raised to power n by g of y equals to x, y tends to w belongs to w, then g of b equals to a, f of g y equals to 0, y belongs to w, equation 2. Therefore, f of g y equals to 0y, which implies g of y equals to f inverse 0y equals to g of 0y, implies g is a c dash mapping of w into r raised to power n, since g is a c dash mapping of v into r raised to power n plus m. It is now remains to show that g dash b equals to minus tx inverse t of y. Let psi y equals to g of y belongs to w, then psi dash y k equals to g dash g k y belongs to w and k belongs to r raised to power m. Equation 3. By 2 we have f of psi y equals to 0 for all values of y belongs to w. Then by using the chain rule we get f dash psi b and psi dash b equals to 0, which implies f dash ab psi dash b equals to 0, which implies t psi dash b equals to 0, which implies t psi dash bk equals to 0 for all values of k belongs to r raised to power m, which implies t g dash b k equals to 0 for all values of k belongs to r raised to power m. So t of x g dash b k plus t of y k equals to 0 for all values of k belongs to r raised to power m, which implies t of x g dash b plus t of y k equals to 0 for all values of k belongs to r raised to power m, which implies t of x g dash b plus t of y equals to 0, which implies g dash b equals to minus t of x inverse t of y, hence proved.